Hi, everyone. Thank you for being here and trying to understand more properly what Web3 is. So today I'm going to talk about this technology that probably most of you have heard of, which is Web3, blockchain, cryptocurrencies, centralized storage systems. Well, there's a lot of technologies linked to this concept, but it is still to be defined probably more in depth what it is. I wanted to start just introducing the framework in terms of the economical frame of how the market actually is. And I'm going to base everything on reports that we can find on the internet. So the last one, it's the one from PricewaterhouseCoopers, but there's also one from Gartner and Boston Consulting Group and so on, and they all tend to say nearly the same. So as you see, there's an estimated growth for the upcoming 3 years of up to an 80%. That's a massive growth for the next years, and it ends up with approximately $2 billion in terms of GDP globally. Yeah? But if I keep going like this, what I'm going to do is just to explain you how relevant Web3 is, and that's not my objective. In fact, I think that Web3 right now seems more a marketing buzzword than actually technology that everyone is using. And I'm not saying that I believe that. I'm just saying that, at least for the vast majority of people, and I'm talking about my father, for example, this is what happens. So my objective today is basically to demystify this and try to explain you what actually Web3 can do for you and for your businesses. Everything that is linked to this needs to be in the current situation and the state of the art that we are working. So I want to quickly introduce something that may be surprising to everyone, but it is estimated by 2030, once again, that digital assets will just represent 25% of this market, even though right now it's the only part that we are seeing or that has a lot of sound around the market. I'm sure everyone has heard about Bitcoin. I'm not that sure that everyone has heard about zero-knowledge proofs. Probably not. Yeah. So what's the vast majority of the pie? The vast majority of the pie is represented by secure information exchanges. Those represented by provenance, identity, and cyber-secure communications. And there's another 7% still to be classified. Yeah? So I'm going to focus everything on this part. Why? Because I want to define the biggest portion of the pie as I can. I have just 30 minutes, and I'm going to try to explain this part. So no tokens, no cryptocurrencies. I'm not going to give you the best advice in investment. So tomorrow, no one is going to be rich, probably, not even me. And let me introduce you the actors that are going to join me in this scenario and with which we are going to work to understand at least 4 use cases, maybe 5, depending on the time, in fact, that I have. So here we have Bob, Alice, and Victor. They're really good people. And we have Chad, a super malicious guy who's wearing a hat. We also have the document and the tampered document. And you might say, well, Jordi, it's kind of obvious that this cross, it's one on the left and the other one on the right. Yeah, that's obvious, but once we start scaling this to the internet, yeah, please tell me which one is the different one. Yeah, it's kind of difficult to find out, but we need to look at things at scale, not just as a simple document. So yeah, I can verify a diploma by calling the university. Yeah, verify this amount of documents. And let's see how many time are you going to take to actually verify it. Yeah? So let's start with this example. Tampering. What's tampering? Let's imagine Bob, who, in this case, I'm going to explain the case of a PCR. Sorry for changing once again. Just it came to my mind, and I think it's easier to understand. PCRs. I think everyone is really familiar with this concept. I don't know if everyone here has done one, but if you are traveling a lot, probably you have done multiple tests. Yeah? So Bob is the doctor, and it's giving us the results. In this case, Alice. So Alice receives the results and goes to the airport and wants to board the plane. So Alice is showing this document to Victor, who is basically boarding everyone, and he checks that everything is OK, and Alice boards. What happens when the malicious chat comes? He can receive a positive result, change the result, and show it to Victor. And there's no way Victor can notice this. I don't know if you have friends that have done this. Me, myself, I have done it. Not changing the result, but just changing the date. And this is a problem. Because if I'm doing it, and I know that everyone is going to say that no one has done it probably, but it's something that's really typical. At least in events where I've met people, 50% of the people in the really beginning was kind of doing this. Yeah? So we need to find a solution to this, and blockchain can help on that. What can blockchain do? And it's not a really massive change. It's basically that Bob prepares the result, Bob registers the result to the blockchain, and everything happens exactly the same. So Bob gives these results to Alice. Alice moves this to the boarding zone, shows these results, but there's the big difference. Victor can check if this result has been modified. Yeah? So what happens when chat tries this? Well, Victor notices about this. So yeah, we've prevented something that's really important, and it's called data tampering. And it happens in communications. It happens with a lot of other use cases. Just think the amount of data that you are moving that you cannot guarantee that the original document is the last document that you are seeing. And to add even more, you are time-stamping it, so you know when it has been issued. So I wouldn't be able to change the date. That's what I did. So right now, for me, it would have been impossible to change that. Okay? So yeah, basically, blockchain solved all the problems. Not at all. I mean, let's go to another option. Look, we have blockchain, but chat still can do something. Yeah, we are registering the document to the blockchain, but what happens if chat says, OK, cool, I will send it myself to the blockchain so that Victor can check, and yeah, everything will look fine. So this is going to be another problem. What's that called? Forging. I don't need someone to provide me with this document because I can forge it myself, and I can just register it and so on. So I need a way, and in this case, it's really obvious because chat can generate, let's imagine, for cosmetics. In cosmetics, we have a big problem. 10% of the real market is fraud. Basically, it's being, products online are being sold that are not even produced by the producer, and distributors are moving products that are false, which in the end have an economic impact. But let's look at it from another point of view. Who's liable for this? Because these products have no quality assurance, so I can have health issues in this case. Chat could do the same, could create labels, the exact same jar, and can distribute it, and the end user wouldn't notice it, even if it's registered on the blockchain. And this is solved really easily, and with something that, well, it's not that new. I mean, digital signature, everyone has used Signature or Validated ID or DocuSign to sign a document. What's the difference? This one is algorithmic. So but basically, it's the same. So I can, just Bob can sign this document, and it's being registered to the blockchain, and the document is signed, basically. What happens when chat tries to do this? It's just impossible. He has no private key to sign this document. So I can guarantee that Bob is the only issuer that can generate the document and not chat. So sorry for chat. This time, we won them again. Another problem, and this one, it's even cooler, and I will link it with the smart cities, for example. So right now, in the European Union, it's really important to have open data specifically for CO2, in terms of enterprises, but also in terms of government. What happens if Bob, who can be an auditor, sends a report to chat who says, well, that's not fine for me, so I'm not going to publish it. Victor, who might be in this case a citizen, wouldn't have the information. And this needs to be resolved too, not just for this case, but also, let's imagine I give you a national ID and I want to revoke it because some detail is wrong, like your age, your gender, or whatever. Would you would have the national ID, but you would also have a document saying that it's revoked. What if I don't show the revocation? Who would notice that this is revoked? So it's a concept that's called availability. And sorry, technical guys, it's really simplified. It's much more difficult in terms of what's happening, and it's not covering even a range of what this problem is. But how do we solve this? Bob not just registers this to the blockchain, signs it, and so on, but he also publishes these documents to a DFS. DFS is a decentralized file system, okay? Just to make a quick comparison, does it sound familiar to you, Emule, Ares, and so on? Yeah, but basically it's that, but a little bit more advanced right now, probably. So that what happens if chat doesn't provide this information? Victor would be able to recover it directly from a DFS. So he would have access to this data. And we are solving another problem. And right now, you should be considering that I'm not talking just about blockchain. I'm also talking about things that are really traditional cryptography, not traditional, but really normal cryptography, not something really new. In fact, the vast majority of what I'm saying, it's cryptography that already existed. And one of the biggest concerns that I couldn't display in this image, it's confidentiality. So I'm saying, like, register this here, you would be able to download, and what about my privacy? Should it be considered or not? Yeah, of course it should. So I divided this in 3 points. 2 of them, I think it's really technology that is already used nearly everywhere. And there's a third one, which is not zero-knowledge proofs. As I said, probably it didn't sound familiar to you. So imagine I'm publishing data. What should I do to protect this data, which I'm not controlling? I should encrypt it. But this is something that's being done for a long period of time. It's called symmetric and asymmetric encryption. What if I register data to the blockchain? You cannot delete information there. Well, you don't register the data there. If you were doing that, probably you would be using the worst database on Earth. I'm not saying that blockchain is bad, but it's not meant to be a database, probably, at least for me, considering permissionless blockchains, which are the ones that everyone can accede, okay? And finally, the third one, and this is a concept that's ultra cool. You'll have to believe me, as this can work. I think right now it can be considered cutting-edge technology, which is called zero-knowledge proofs. So it's like, I need to, let's use the case of the PCR. Alice needs to prove that he have a PCR result which is positive, but don't want to give any other details. So a zero-knowledge proof enables you to prove that you own a certain data without even revealing it. Okay? What's the case for this? Alice would be able to prove that he has a negative COVID test without even revealing her name. Just think in places where this can be used, KYC and so on. It's not just for the PCR, but I think it's a good example. And this is composable, so we can add requirements and so on to this. So like I need a PCR test plus 18 years and so on. Now with all the concepts, let's try to explain how a digital identity works. And I mean, it's one of the core modules of Europe right now, how trust services are being moved in terms of digital identity, signature, trust services, and so on. I keep the same actors. We have Bob, who is the issuer. We have Alice, who will act as the citizen. And we have Victor, who is going to be the verifier. Bob is going to be the police. So Bob is the guy who issues national IDs. Alice wants a national ID because he wants to vote. in the future, at least, in a future election. So he presents herself to the issuer, to the police, and gives all this information. Like, I don't know what right now is required, but I think it's your national ID card and some other data that you provide, and a payment also, yes, because there's a lot of work there. And Bob will issue a verifiable credential to Alice, who will receive it in his mobile phone, her mobile phone, sorry. In the end, it's kind of close to what's happening right now. The difference is that it's digital, but they're giving me a physical card. So the idea is the same. I have the custody of this data instead of the custody of a digital card. How can Alice work with this? Well, if we give directly this data to Alice and we do not register it to the blockchain, now I have added the fingerprint proof, the fingerprint sign here, because it's not the data itself, it's just a hash of it. If Alice wants to use this data, it needs to be registered, just because if not, maybe she would change some data, for example, nationality and so on. What can Alice do? Let's imagine that Alice wants to vote. He needs to prove where she lives, at least to choose the ballot where she's going to vote. So Victor will ask Alice her credential, like, sorry, can you give me your ID card? This happens right now. It's exactly the same, but digital. So Victor will ask for this information, and Alice will basically provide it. Let's imagine the easiest case. So she provides it plainly. Right now, it's what's happening. I'm giving my ID card, at least here in Spain, and you infer all the details on who I am. Even though, and it's crossed out on a list, which could be better or not, we would see that. But Victor is inferring the details. So let's keep this model, and then we'll go to how to do it without transmitting data over the internet. Victor verifies this data and says, yeah, cool, she has all the requirements satisfied, so she can vote. Let me check if this credential has not been modified. So he checks it to the blockchain, and afterwards, yeah, okay, cool, you can vote. What happens if we want to do it privately? Alice can generate a zero-knowledge proof and send it to Victor. Victor will infer zero details on any of the, for example, Alice's name or whatever, and will still be able to validate that he has she fulfills the requirements to vote. So in this case, without inferring any details, Alice would be granted access directly to voting. That's really important, not just for voting, anonymous, but at least when you do it digitally, but also for the health sector, for example, and also for when you log into certain web pages and so on. Yeah. So I want to end this by trying to give our definition of what we should describe Web3 as. For us, Web3 is the source of trust for secure information exchanges. Those meaning that it's the layer of security that any platform should have to protect and guarantee everything without a third party. I don't care if it's a crypto transfer. I don't care if it's about data. I don't care whatever. What you need is something you can trust. So that, and let me go back, you don't have to trust technology, because technology is trustless. What you need to trust is people who is interacting with it. Because this tends to be the worst part where at least cyber attacks focus. Why? Because it's the point where it's easier to attack. But right now, how we are working, it's with trust services that we give them this credential. But technology has surpassed this state of the art, and right now it's currently available to do everything without having to trust anyone. And that's the main point of it, basically. So all regulations are moving here, are being moved. We have EPSI infrastructure, we have ADAS2, which is coming, which is qualifying electronic ledgers as another service, trust service provider, trust service, and then we have trust service providers on top. But in the end, technology has advanced, and we can guarantee that this is currently being done. So we at Bloock believe that this is Web3. I know that it may be a little bit different from others. I know that you can find a lot of information on tokenization and so on the internet, and probably it's going to be totally different, this definition. But in the end, if you go to the root, probably everything will come to this. So we've been building for the last 2 years something to work with this and to make ease enterprises to join this. And it's basically the simplest framework to streamline cyber-secure communications, leveraging Web3. So thank you, everyone. I expect that it has been useful, at least what I've explained, that we have a more clear idea on how this can apply, and that I have moved something out of your mind from crypto space to what we actually can do and what applications we can develop on using this technology. Thank you so much.